So now we are calculating sample standard deviation because we are usually, and I can say always, use sample data instead of the population data. Or when we say standard deviation, we mean sample standard deviation. So the population parameter, that's the conceptual thing. So we don't use them a lot, but sample standard deviation, we use them a lot. So again, when we say we need to calculate the standard deviation, that means sample standard deviation. So simply, the process is very same. Average and find the average here. So you can see the average is here, and then each case minus 6.33 as the average, and then in the same and square the deviation score. So I told you that had to mean the square. Okay, then type down. The sum of the square is sum of those numbers. Okay, you need to make sure that n minus 1 is the denominator. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 cases, but that will be 9 minus 1. So denominator is 9 minus 1. So sample variance is sum of the square divided by n minus 1, right? And the standard deviation, I mean the sample standard deviation is RT, the square root sample variance. Okay, so 1.8. So it's a little bit bigger than 1.7 we had for the population parameter or population standard deviation because we have the adjusted denominator. So when we calculate sample standard deviation, you need to make sure that you are using n minus 1 instead of n. All right? So this is the application of the alternative equation when you have many cases. So you can start from the sum of the squared x's. So squared x's can be created as your number and had 2. So it will be 509 and then handle. So in the same size of the matrix, I mean, because you have 3 multiplied by the 5 matrix, you can create the same. And then you can create SUM, open the bracket, and add them up. Okay. Right. Then you have the sum of the squared x's. So this part is done. And this is the squared sum of the scores of the x. So squared sum of x. Then you can simply add them up. So these are the raw scores. And so this is the sum of x. And you want to find the squared sum of x. So the same way, squared. Right, so this is a squared sum of x. So this part and then sum of the square. So this is the n minus 1. So we can see these are 5 and 3. So it will be 15 minus 1. All right, and sum of the squared deviation scores will be then, so this one is here and minus this one. So squared sum of the x's divided by number of cases. So make sure that is using n instead of the n minus 1 here. So there are 15 cases. Okay, and then sample standard deviation is SQRT. Okay, this one. So SS sum square divided by n minus 1 and close the bracket. Okay, so we can see the standard deviation is 50.